Earth and Space Science Regents Review 2025, full global guide for USA, UK, Australia, Germany. Ready to ace your Earth and Space Science Regents in 2025? Whether you're a student in New York or a curious learner in the UK, Australia, Germany, or across the globe, this in-depth 40-minute review covers everything you need to know, from plate tectonics and weather systems to astronomy and climate change. We'll explore Earth's internal layers and global tectonics, USA, UK, Germany, Australia examples, weather systems, ocean currents and atmospheric patterns, climate zones and global warming impacts in different regions, the rock cycle, erosion, deposition, and Earth history, astronomy fundamentals, eclipses, tides, star life cycles, and more, human impact and environmental sustainability. Designed for Regents prep but relevant worldwide, this review is packed with visual references, real-world case studies, and tips to master your exams. Let's make science global, understandable, and unforgettable. Like if this helped your exam prep, comment your toughest topics, subscribe to Future Way Education for more advanced science content across disciplines.
257 257 1 2 3 4 5 6 7 8 9 0 257 257 25.
Earth and Space Science Regents Review 2025, Global Prep Edition for USA, UK, Germany, Australia. Welcome to Future Way Education, your global destination for mastering science, technology, and the universe. Today, we're diving deep into the Earth and Space Science Regents Review for 2025, designed not only for New York State students preparing for their Regents exam, but also for curious minds in the USA, UK, Germany, Australia, and beyond who want to truly understand how our planet and our universe works. This isn't just an exam guide. It's an intellectual journey into the Earth's inner core, up through the atmosphere and beyond the stars. You're about to experience over 40 minutes of in-depth exploration, filled with insights, memory hacks, and real-world connections to keep you hooked from start to finish. So take a deep breath, stay curious, and let's begin. Let's start with Earth structure and plate tectonics, because the entire surface of our planet, every mountain, valley, earthquake, and volcano starts here. Earth's internal structure is layered: the crust, mantle, outer core, and inner core. The crust is broken into tectonic plates that float on the asthenosphere, a softer, ductile part of the upper mantle. These plates are in constant motion due to convection currents driven by Earth's internal heat. Think about it. Every time you feel an earthquake in California, a volcano in Iceland, or a mountain forming in the Himalayas, you're witnessing plate movement in real time. In the USA, the San Andreas Fault is a classic example of a transform boundary, where two plates slide past one another. In the UK, ancient geological collisions helped form the highlands. Australia has the Great Dividing Range, and Germany experiences moderate seismic activity because of complex tectonic stress from the Eurasian plate. Understanding divergent, moving apart, convergent, colliding, and transform, sliding boundaries is critical. And real-world examples help ground this in reality. Now let's dive into weathering, erosion, and deposition. Weathering breaks down rock, erosion moves those sediments, and deposition lays them down in new locations. It's the story of how landscapes evolve over time. In Germany, the Rhine Valley has been shaped over millennia by glacial and fluvial erosion. In the USA, the Grand Canyon was carved by the Colorado River, a masterpiece of weathering and erosion. You must understand both physical weathering, like frost action, abrasion, and chemical weathering, acid rain, oxidation. Deposition plays a role in forming deltas, beaches, and riverbanks. And in regions like Australia's outback, where wind is the primary erosive force, you'll see the power of aeolian processes. Next up, Earth's atmosphere and weather systems. Our atmosphere is a layered blanket of gases, from the troposphere, where weather happens, to the exosphere. Weather is controlled by energy from the sun and Earth's rotation. High-pressure systems bring clear skies, while low-pressure systems bring clouds and storms. Cold fronts move quickly, often causing sudden thunderstorms, while warm fronts lead to gradual weather changes. Why does this matter? because understanding these patterns can literally save lives in hurricane-prone areas like Florida or typhoon-exposed coastlines in Australia. Even in Germany and the UK, jet streams and Atlantic currents influence temperature and precipitation patterns. Know your cloud types? Read isobars and recognize frontal boundaries on a weather map. These will all appear on your exam and help you understand your own skies. Let's now shift into the water cycle and climate patterns. Evaporation, condensation, precipitation, runoff. This cycle is the heartbeat of Earth's weather and climate. But climate isn't just weather. It's the long-term pattern over decades. What affects climate? Latitude, altitude, ocean currents, and topography. The UK's relatively mild climate is largely due to the Gulf Stream, a powerful ocean current transporting warm water from the Gulf of Mexico. In contrast, the central parts of Australia are arid because of continental positioning and atmospheric circulation. Climate change is a hot topic, pun intended, and for the 2025 Regents and global understanding, you should know how CO2 levels, greenhouse gases, and human activity influence long-term weather trends. Now we'll explore Earth's history and geologic timescale. Earth is 4.6 billion years old, and we know that thanks to radiometric dating techniques like uranium-lead and carbon-14 dating. In this section, you need to understand the difference between relative dating, younger or older based on position in rock layers, and absolute dating, numerical ages from radioactive decay. Fossils are the key to unlocking Earth's past. Trilobites, ammonites, brachiopods, each helps us understand ancient environments and evolutionary change. In Germany's Solnhofen limestone, for example, we found Archaeopteryx, a dinosaur bird transitional fossil that changed our understanding of evolution. In the USA, places like the Petrified Forest and Wyoming fossil beds reveal life from millions of years ago. Let's move into mapping and the Earth Science Reference Tables, ESRT, a Regent staple. Contour lines, gradients, isolines. Learn how to interpret topographic maps and calculate slope, change in elevation over distance. You should know how to find specific data using latitude and longitude and understand how map scale affects measurement. These skills aren't just exam tools. They're used in GIS systems globally, in everything from environmental monitoring in the UK to urban planning in Australia. Let's now go beyond the surface, to astronomy and space science. The Earth's rotation causes day and night. Its revolution causes seasons. But here's where it gets cool. The tilt of the axis, 23.5 degrees, creates seasonal variation. And depending on where you are, the USA, Germany, Australia, the seasons flip or behave differently. The moon's phases and its revolution around Earth cause tides. Spring tides during full new moons, neap tides during quarter phases. Learn your eclipses. Solar eclipse, moon blocks sun. And lunar eclipse, Earth blocks sun from moon. The solar system consists of terrestrial and gas giant planets, and understanding their orbits, positions, and compositions is often tested. Let's go even deeper into the universe and cosmology. What is redshift? It's the observation that galaxies are moving away from us, a key piece of evidence for the Big Bang Theory, our leading explanation for the universe's origin. Add to that the cosmic microwave background radiation, and you've got a universe that began with a bang and continues to expand. Star life cycles, from nebulae to protostars to main sequence stars to red giants or supergiants, and ultimately to white dwarfs, neutron stars, or black holes, are fascinating. Understanding Hertzsprung-Russell, HR diagrams, and stellar classification is often one of the more advanced parts of the Regents. Now let's discuss environmental Earth science, including human impact. Global warming, deforestation, sea level rise, melting polar ice, these are more than just talking points. They're critical scientific realities. In Australia, coral bleaching of the Great Barrier Reef highlights climate stress. In Germany and the UK, rising temperatures have shifted native species and seasonal rainfall. In the USA, we're seeing stronger hurricanes and wildfires linked to a warming planet. Know your renewable versus non-renewable energy sources, understand the role of carbon sinks, and be able to discuss sustainability. These are real-world issues that demand educated action. To close, remember that Earth and space science isn't just about memorizing facts. It's about understanding the system we live in. From the soil under our feet to the stars above us, this course connects geology, meteorology, oceanography, and astronomy into one interconnected, awe-inspiring web. Whether you're in New York, London, Berlin, or Sydney, the principles remain the same. The Earth rotates the same. The sun rises and sets the same. And science, good, solid observational science, is your best tool to understand it all. Conclusion, call to action. If you stayed with me through this global 40-minute Regents review, congratulations. You're not just exam ready, you're globally science literate. Like this video if it helped you. Drop your questions below for custom answers. And subscribe to Future Way Education for more advanced review sessions, AI learning tools, and science mastery from across the world. Good luck, and may the science be with you.